Welcome to part 3 of Competency 13. In this video, we will work with methods of counting. Number 1. In a room of 9 Republicans, 7 Democrats, and 4 Independents, a special committee of 3 people must be created. The committee must have 1 person from each political group. How many different committees are possible? Okay, the key to this is that you already have 3 groups. So that means 1 person from each group. Well, it's already set up for your outcomes, and that's what we need. Total outcomes is also total committees. All right. So we have 9 times the 7 times the 4, which is 252 possible committees because they're already split up. Luckily, the instructions implied what they needed. Okay. It also implied our operation, to be honest. All right, so let's look at number 2. Let's see. Okay. A student is selecting courses for next semester. The student must take a course from one of the following different courses, or rather, I suppose, categories from each subject offered. Okay, so you have to take one of each. Well, that is 5 categories and one from each. Well, that just means that you're multiplying all of those possibilities together because the question says if the student is eligible to take any course, how many different schedules are possible? So they're not limiting us to only taking, say, 4 subjects. In this situation, they're saying that the student can take 5 courses. I think that's a lot, but that's what they're saying. So, how many possible combinations do we have here? Well, you're going to multiply everything together. However, history only has 1. So, you can include it, not include it, it really doesn't matter. So, we have 3 times 5 times 4. And then, oops, that should be a 4. Type over that. Okay, there we go. 4. And then times the 7 and enter. That would be 420 possibilities, schedule possibilities. Number 3, suppose a vehicle license plate has 5 characters. This would imply in the US with the requirements listed below. Okay, you have letters, numbers, or letters, numbers 0 to 9, or letters. Now that would be for the 1, 2, 3 middle values. And then on the end, the last character would be 0 to 9. So that's a possibility of 10. How many different license plates are possible? Okay, so what we're really doing here is this. How many letters are in the alphabet? 26. Okay. However, that needs to be multiplied too. Okay. 1, 2, 3 in the middle. Okay. And that is here. I am going to put a parentheses and 0 to 9. That would mean there are 10 of them. Or letters, 26. So, or tells me that I'm going to add those 26. Now, think about it. You have numbers or letters. Well, that gives you 10 plus 26. That's 36. Now, there's 1, 2, 3 of them, 3 of these situations for 3 different characters. So, we're going to have to multiply those together. Well, I'm going to say that's to the 3rd power. I'm just simplifying it out for myself. Now, the very last character is 0 to 9. That's 10 possibilities, so that is times 10. Okay, so let's push enter. Okay, and there we go. And that is actually correct. Okay, nice long number. That's quite a few possibilities. Okay, that could cover a lot of drivers. Okay, let's go to the next one. For the next one, it says that number 4, well, we're going to be working with combinations, by the way. From a group of 15 students, how many different groups of 10 are possible? Well, when it says groups, it's a combination because order does not matter. So we simply need 15 would be our total, and then push your probability. You want number 2, and then after then, well, we want 10 out of that 15. But this is a combination, so we're going to let the calculator do the work for us. So that would be C. Okay. Now, for 3 and 4, how do I know this? Well, it's very obvious that a license plate is a combination, not a permutation, because there aren't other restrictions with this question. Now, they could have put other restrictions, such as you can't repeat a letter or a number from one character to the next. But that's not what the question was. So it was a nice combination of total outcomes. We just multiply it all together after we figure out what they've given us. Okay. And then this next one, well, obviously it's a combination because it says how many different groups, how many different combinations if we only select 10 out of the total. Okay. All right. Let's look at number 5. Number 5. A school PTA has 11 parents and 7 teachers at a given meeting. If a committee of 3 people needs to be selected, how many different committees are possible? Okay, they're trying to confuse you a little with the warning, but the reality is we just need the the possibility of taking 3 out of the 18. And what do I mean by this? It's a combination. How many combinations of 3 people can we develop or create out of the total of 18? Okay, so then what do we have? We need our 18, then prob and go to 2 because it's a combination. Order doesn't matter. And then we need 3 out of that. Okay, push enter. And that would be the correct answer, 816 combinations. Okay, now let's look at number 6. From 25 available players, a coach needs to select a team of 9 players. If the players can play in any position, how many different teams are possible? Well, the wording tells us order doesn't matter, so that when it says any position, that says, hey, this is a combination. And then to follow that, it says different teams. Well, obviously, a team doesn't have a particular order in itself, so that also confirms a combination. So we'll do the same thing. Say 25, prob, and 2, and then we need 9 out of that, and press enter. And there we go. Ooh, that's quite a few. That's pretty significant. All right, the 204. Actually, that's even bigger than that. That's great. That's A. Okay. All right. Obviously, the others wouldn't apply at all. I'm thinking that some of them are just simple. I have a feeling that B and D would be multiplying the values together incorrectly somehow. And then C is probably a permutation. But let's not waste our time finding out. We know which value is correct. Okay, now let's move on to number 7. 10 people are lined up in a row to take a photo. How many different arrangements are possible? Okay, as you see above, it's giving us a clue that this is a permutation. Well, what really honestly tells us when you're asked a question like this, okay, you have 10 people, and then they say we line them up. Anything in a line implies a permutation because once someone takes a position in the line, they cannot take a position anywhere else in the line. So we know that that's what we've got. So let's see what's going on here. Well, we have 10 people, but it doesn't have any other restrictions. Okay. What they really mean is we need all of the 10. So that is 10 people out of the 10 in a permutation. So 10, prob, number one. So go ahead and enter, and then 10 again. And what do we get? That nice significant value that is option D. Okay. Now think about it. A and B, those really don't look large enough to me, but be careful. Make sure, go back, always look, make sure you're typing it in. And in this case, I know that we've got the right selection. Once you get used to these and you start reading, you get the clues and the wording and you understand. And the biggest clue for me is they didn't say we're taking any other groups out. Okay. All right, let's go on to number 8. Number 8, how many different ways can all the numbers of the word banana be arranged? Okay, this is a very popular question. What it is you have a permutation. And first, you know it's a permutation because the arrangement, meaning the order of any word, does actually matter. And you have repetition of letters in the word banana. Okay. So what you have to do is take the total of the permutation, all of the possible permutations, which is we have 6 letters. So that'd be a 6 out of a 6. So let me set up our fraction. So I have 6 prob. Number one's what we want, and then 6. Okay. You take the total and divide it by each repetition. Okay. Well, how many repetitions do we have? We have 2. A has 3 and N has 2. Okay, so we have 3, prob, enter, and 3. Now, the key is to make sure you push multiplication in between. It looks a little odd, but this is all that you need to do. It's just the difference in this calculator, that's all. Okay, so now let's do it again. Remember, we have N has 2 letters, so we're dividing by that repetition. So 2, prob, enter, and another number 2, enter again, and 60 is what we need. So there are 60, how many different ways? There are 60 ways to arrange these letters. There's 6 letters with the repetitions. Okay. All right, so now let's look at number 9. Well, looks like we have the same thing going on. Oh, and this is a super popular question. Mississippi. I couldn't tell you how many books I've seen that in. One of these days, if you're curious about this, go look it up. If you have a math book, go look for it. I think I found it in 3 different books, actually. Okay, even an algebra book. We didn't do it in class, but it was there. Anyway, let's just do the same thing. So set your fraction up. Ooh, but we have 2, 4, 6, 8, 10, 11 letters. Okay, so 11, prob, course number one's what we want. Type your 11. Remember, we want the total possibilities, which is the 11 out of 11 for this permutation. But now we divide by the repetition. Okay, we have 4 I's, 4 S's, and 2 P's. Okay, so 4 prob, and then 4 again. Remember, you must enter everything and then multiply. But we have another letter S that has 4, okay, in it, 4 repeats. So 4, prob, number 1, and 4 again. Now again, make sure you have your multiplication. So P only has 2 letters. So 2, number prob, number 1, that means just enter, and then push 2 again. So now I have all of the 3 repeated letters accounted for. Okay, push enter, and there we go. Option B, and that's exactly what we needed. Okay. All right. This is the last question in this video. I wanted to thank people for their wonderful comments. Someone told me today that they really like the videos and it's helping. That made me feel good. Thanks, guys. I'll make you some more. Okay. And again, you guys are wonderful liking, sharing, and subscribing. Happy testing, everybody.